now let's look at another type of transformation. Let's look at vertical stretching and vertical shrinking. So when you multiply all the y coordinates by the same positive factor greater than 1, the transformation is a stretch. So let me give you an example. So if we have absolute value of x and we multiply it by a whole number, let's just say 8, that's a vertical stretch by 8. Now let's look at the other example. When you multiply all y coordinates by the same positive factor between 0 and 1, the transformation is a shrink. Now it says positive. I always want us to think about this, that the value is between 0 and 1. So what are some numbers between 0 and 1? Well, we can think of a half, 1/2. We can think of 0.5, 0.6, and things like that. I'm not going to say that they're just fractions, because there are fractions and decimals, for example, that are greater than 1, right? So can you think of an example where a fraction is greater than 1? So an example would be 3/2, right? So that is still a vertical stretch, right? That's greater than 1. So think about vertical shrinks are when it's between 0 and 1. So vertical stretch, those will become narrower. So just to talk about that a little bit, they become narrower, while vertical shrinks become wider. Okay, so narrower would look very, very narrow like this. Wider would be something like this. Okay, more like a, more flat. So let's look at graphing and describing stretches and shrinks. So we have g of x equals 2 absolute value of x. So let's graph our parent function first. It does ask us to graph each function and its parent function. So let's graph the parent function f of x equals absolute value of x. So again, that starts at 0, and our slope is just 1 in this case. Oops. Here. Now let's label it f of x. Now the transformation, we have a 2 in the front. So it's a number greater than 1. So we're going to say it's a vertical stretch. And let's say by a factor of 2, please. So vertical stretch by 2. So just, more information is wonderful. So vertical stretch by 2. So let's just do it once with plugging in numbers, right? So if I plugged in a 0, 2 times the absolute value of 0 is just 2 times 0, which is 0. So it's still here. If I plugged in 1, I want you to see what happens. 2 times 1 is now 2. So if I plug in 1, I get a 2. What if I plugged in a 2? So 2 times 2 is 4. So look at the slope here. So and look at 2, we go up 2, right 1, up 2, right 1. What's going to happen on the left side? What does this look like? Well, it's just going to be up to left 1, right? Up to left 1. So it's still making that V shape. So for absolute value in this case, you can kind of think about it as what's the slope? Rise over run. So 2 over 1. And so this is our g of x. So this example here, 1/2 x. So I'm going to pause the video, see if you can try this out. What do you think this is going to look like? So first of all, I hope you graphed your parent function here. So it's still the same. And it's good to see the comparison of what it would look like. Now we have 1/2 in the front. So that's a number between 0 and 1. So we're going to say it's a vertical shrink by a half. So there are horizontal shrinks. So you just can't say stretch and shrink. You need to say specifically vertical stretch or vertical shrink. In this case, it's by a half. So again, if we plugged in a number, if we plugged in 0, it would be 0. I want to plug in 2 instead. I don't want to plug in 1, because if I plug in 2, I'm really 1/2 times 2, right? Just doing the algebra involved in this. The 2's cancel and it's 1. So I plugged in 2, I would get 1. Okay. Now I'm showing you the algebra so you can see what does the graph look like? Where did the numbers come from? And then hopefully as you get more comfortable, you'll be able to notice the pattern, which is really what we want, noticing the pattern and being able to use it. So for absolute value, 1/2 is that. And what if we plugged in 4? 4 is a really nice number. So because we're looking at 1/2 times 4, half of 4 is just 2, right? So you plug in 4, you get a 2. So 4, you get a 2. Plug in a negative, it's just going to go on the other side. Now I want you to notice the pattern. So it's going up 1, right 2, up 1, right 2. So what I said earlier about that kind of being our slope, that'll really help you out on these graphs, right? You don't have to plug numbers in. You just have to recognize the pattern to help you out. And this is our h of x, and here is our f of x. Now let's do a combination transformation. We did one kind of right up here already for number 4 when we said it was reflected, and then up 4. Let's do that here. So let's take a look at the equation. Again, we want to always read it from left to right. It's really important because when we start to write equations, the order does matter. So let's take a look at from left to right. What does this negative mean? What do you remember that means? So that means it's reflected across the x-axis. So we know it's going to be reflected across or over the x-axis. What does this 2 and the inside mean? So it's plus 2. It's always opposite. So this is actually moving left 2. Then the last one, minus 3 at the end, that means we're going down 3 units. So first of all, let's graph our parent function. Our parent function, f of x equals absolute value of x, and then we're going to transform it. Okay, so here is the absolute value, graph this way. Now what we want to look at when we graph, as a hint, is I would look at the shifts, right? Whether it's moving left, right, up, or down. So we know that it's moving left 2 and down 3. So we're going to take this point right here, left 2 and down 3, and that's where that new point is going to be. So let's graph that. Left 2, down 3 is right here. Now let's look at, it's not stretched any, right? It's just a negative value. It's reflected over the x-axis. So again, if you think about slope, negative slope, it's just going to go right 1, down 1, and then right 1, down 1 again, right? It's reflected, so it's going upside down. So what I like to do when I look at these, just to double check that I did it correctly, so I'll say, well, this is our g of x here, and then the f of x is blue here. So when I want to double check it, I look at, did I do everything? So number 1, look at the words that you said. So reflected over the x-axis. So reflected means it's going to go the opposite direction. So instead of opening up, it is opening down. So I did that correctly. Then I know, so here, positive 2 means left 2. So I moved left 2, that's true. And then I moved down 3. So I did do all these things, and so that is my combination transformation. Again, just to talk about it, just students that make, the common errors I see students make is that, number 1 is that they do say these words, they name it correctly, but it's interesting because when they do their graph, they do something a little different. So as a hint, do what you say, do what you write, and I think that will really help you out in graphing these combination transformations.